Hello everyone, this is the part 3 foundation topic on OSPF video series, and in this video we'll look into OSPF LSAs and LSDB. Let's take a look. Link State Information Exchange. So this is the second main phase of OSPF. In our last video we looked into the first phase, which was neighborship, how routers become neighbors. So once that process is complete, it moves into this phase where they start exchanging database information. So neighborship between routers allows routers to exchange their database. Two-way state means routers is available to exchange is LSDB, which stands for Link State Database. So two-way state, that is the state we focused on our last video. When routers becomes neighbors, it moves from init to a two-way state. So that state basically means routers are ready to exchange their database two ways. So database exchange, once a neighborship are formed, it goes through a several state for that exchange to happen. So we'll look into that one now. What are those states? So first state is down, right? So this is a state where two routers are connected, their link is down, OSPF is not configured, right? So this is a very initial phase. So everything is down, right? So you configure OSPF, you bring the link up, it starts doing the hello message. That's the detailed information we looked into our last video. Once that happens, it moves into an init state. And once the init state is completed, it moved into a two-way state. So if you are confused about this down init two-way state, it is very important to understand. So if you are still confused, I would recommend looking into our last video, the foundation topic 2. That's where I cover this topic in a very detail. So once the two-way state is formed between two routers, the next step after that is a DR election, and this is optional. So this all depends how the topology information is, right? So if you have a point-to-point link, you have two routers connected on a serial link, this step is skipped. There is no need for a DR election. But if you have routers on a shared medium connected using Ethernet, such as you have a switch in between, on those kind of topology, you will need a DR, BDR election. So it depends on the setup. So once this step is complete or skipped, it moves into a state called XStart. So XStart, it is a state where a master and a slave relationship is determined between two different neighbors. So the router with the highest router ID acts as the master during the exchange process. So they will go through this election. Whoever becomes the master that has a highest router ID will start exchanging the information first. So once XStart state is complete, it moves into exchange state. So this is a state where they start exchanging the summary of LSDB. When they exchange, when there are two routers, they start exchanging database. They don't exchange entire database. It kind of works like a checklist, and then they will send that information to their neighbor, and their neighbor will check, hey, these are missing on my database, so I will just request you that versus flooding me with everything you know. So the exchange information, like I said, this is a summary of LSDB, Link State Database. We'll look into this in a little bit, what exactly LSDB means. And then moves into loading. This is where, the LSR, Link State Request, they start requesting, these are missing information from me. I want you to start sending me that. So that's where the loading phase happens. And once that is completed, it moves into a full. So full state basically means the two routers has completed the exchange of their databases, and they have the exact same information of the topology, and that is the full and the final state. So in our last video, we looked into a two-way state, and in this video, we'll focusing on full state. So routers, they must be in a full state before they can start routing the traffic, which is important. So moving forward, let's focus on this topic. So we have talked several times. What are LSAs? What are LSDBs, right? I mean, we have, when I said like we have not covered it, but we have talked about it. So let's understand what LSAs and LSDBs are. LSA, it stands for link state advertisement. So LSAs are considered database structure. So they are like building block of LSDB, which stands for link state database. So LSA, so there are different types of LSAs. So there is LSA type 1, type 2, type 3, so on up to type 10 and type 11. So each LSA contains different information. So individually, LSA, they act as a database record. So each LSA are responsible for holding different information, but once combined, once all different types of LSAs are combined, they describe the entire topology of an OSPF network. And all LSAs will basically sit inside LSDB. And LSDB is a database that contains all LSAs. So that's the main concept between LSAs and LSDB. So this is what I mentioned earlier. LSAs are considered data structure that sit inside LSDB. So once router receives LSAs, it is stored inside LSDB. Same thing, what we just talked about. LSA has an aging timer of 30 minutes. So every 30 minutes, LSAs are refloated between neighbors. So, so like we covered, there are different type of LSAs. So each LSA has different timer. So that way, the router CPU and everything does not get saturated. So those are sent in different times. So this is a graphical view of what are LSDB and LSAs. So as you can see there, so LSDB is think that as a bucket that contains LSAs or inside, and LSAs are like the building block, right? The all combined, it completes the entire topology of LSDB, which is the link state database. So let's take a look how LSAs exchange process works. So after two neighbors decide to exchange databases, they simply do not exchange the entire database, but rather what they do, they start telling each other the type of LSAs those are present in their databases. So even when they tell so basically say like, for example, router 1 starts telling router 2, hey, router 2, I have type 1 LSAs, type 2 LSAs, type 3, and so on. And they will just think this has a checklist. They don't send the entire detail on that LSAs, but they will just kind of advertise saying these are the type of LSAs I have. And then so that will help the neighbor router to go through its own checklist, and then it will check what LSAs are missing, so it kind of start requesting those LSAs. So routers then checks which LSAs it has and asks the neighbor router only the LSAs that it does not have, and it uses link state request. So LSAs are not packets, right? So we talked about this one. So LSAs are actually considered data structure. So if once router acknowledges, once router realizes it's missing some LSAs, it will use link state request to get those information. And that's where link state update comes into the place. So once router will use LSU link state update to send LSAs. And LSUs are OSPF messages that actually sends the LSAs between neighbors. So this is how the LSAs gets exchanged. In summary, one more time, two routers becomes a neighbor, and then they start telling each other the list of LSAs present in their own databases, and each router goes through a checklist saying, okay, I have this one, this is what I'm missing. And once router realizes these are the LSAs, those are not present in their LSDB, it will request the neighbor router to send those LSAs using LSR. So LSR is sends LSR link state request packet. The neighboring router receives that. It sees what LSAs the neighboring router is requested, and then it sends that LSAs using LSU, link state update. So it puts the LSA inside LSU and then sends that information to the neighbor router. And once the neighbor router receives it, it'll basically acknowledge saying, okay, I have received it. And that's how OSPF routers will have the exact same copy of LSDB. So all routers will, at the end of the day, will have the exact same copy of LSDB, which will help each router to, independently build routes, as all routers will have the exact same information, a full topology, and that's what a link state routing protocol does. So yeah, so this is it for the foundation topic about LSAs and LSDB. So in our next video, we'll cover the another phase of OSPF. The phase is building the routing table, how router adds the best route in its routing table. So in our next video, we'll look into Dijkstra SPF, the shortest path first, how it works, and how router chooses which route to add into its routing table. So I'll see you in my next video. Until then, I'd like to thank you for watching.